Hello everyone, welcome to Practical Mechanics. I'm Mohsen. Today's video we learn how to draw Mohr circle and how to calculate principal stresses, normal stresses and principal shear stress, maximum shear stress inside the material. From combined stress part 3, we reached to this conclusion that when we apply to a shaft 150 transverse shear force load and for 200 torque and an axial load 4000, we reached to four types of loading: bending stress, torque, shear due to torque, shear, horizontal shear stress due to transverse shear force, and also axial load 4000, which is applied here, produces a normal stress due to axial load. Then we have two normal stresses and we have two shear stresses. We combine together in four specific point. And because bending is the maximum at the base, the fixed end of the shaft, then we consider elements A and B, point A and B and C, D over there. And for an element at A here, if we consider an element, the state of stress for this element is equal to that I show it here. Normal stress 795 and shear stress clockwise is 334. Remember, in this phase that is called phase A, this A has nothing to do with the point A here in the shaft or the cross sections. That for Mohr circle, these two stresses produces a point on the Mohr circle which is called the point A. In most of the textbook, they call it point A. And because this element is in balance, in a static equilibrium, we have a certain shear also, horizontal shear stress, the same here. There is no normal stress acting in y direction. This is what we calculated. There is no sigma y here. Then you have 2 points in this state of stress. First, one point which represents the point A is this surface. We call it A, that is x coordinate is 795 psi, y coordinate, our coordinate is 334. Another surface is the surface number 2. We call it point B. Normal stress is 0 and shear stress minus 334. Why minus? Because it is counterclockwise. In some textbooks, they take clockwise positive and counterclockwise negative. We have to stick to that. And if you think that clockwise is negative and counterclockwise is positive, nothing changes. Okay? Then we draw two axes normal together, and the horizontal axis play the role of normal stress, and vertical axis play the role of shear stress. Then we have coordinate of 2 points here. Coordinate of 2 points, 795 and 33. You must use a roller actually to draw it. It is here, for example, assume 100, 200, 300, 400, 500, 600, 700, 800, 795. We reach to this point. 795. And what about the 334, which is clockwise considered positive? 1, 2, 3, 334 is here. Then find out point A in Mohr circle. This represents this surface. Point A represents the surface, right side surface of the element. This is called a state of stress. What about point B? Sigma is 0. We are it here, and we must go down minus 334. Exactly the same as this value. This is point B. You must connect these two together. And we have a diameter AB, and center of Mohr circle is intersection of the horizontal axis with this diameter line AB, which we called it point C. Okay? Then draw the circle, Mohr circle. Because it moves and it cannot be fixed very good, we just put the point A or B. Okay. It's not touching, we must pass B as well. Okay. We accept it. Then it intersect horizontal axis, sigma at 2 points. One of them is called the largest, sigma 1, the smallest, sigma 2. These are called principal stresses. At these 2 points, which make a 180 degrees in Mohr circle with respect together, any angle on Mohr circle is doubled with respect to any angle on the element. Okay? Then there is also another stress here, which is famous and is called tau max. You can draw tau max here. On both sides. This is tau max. Value is here and here, minus and plus. Then you must measure from point O, origin of the coordinate, to sigma 1. You will find out this is 80, this is 90, maybe sigma 1 is 90, 20. Approximately. If you wanted the exact value, you must use formula for Mohr circle. Maybe you reach that. And what about sigma 2? Sigma 2 is negative, and if this is 100, it should be 120, something like that, minus. Then sigma 1 is 920 tensile, and sigma 2 is minus 120 compressive. You see, it is 920. We never reached to that in our calculation. The maximum that we get in our calculation is 795. Then we can use Mohr circle. Actually, here is a two-dimensional Mohr circle to find out maximum stress that can happen inside the material. Real Mohr circle is 3D, but in engineering, you can actually reduce many 3D problems into 2D and calculate the stresses. And this answer is satisfactory for three-dimensional as well. Many problems can convert from 3D to 2D to make the calculation easier, faster, and shorter in time. But not all problem can be converted to a 2D problem. And then tau max is a principal stresses as well for tau max. These are two, the sigma 1 and sigma 2 are called principal stresses. And we find them by Morse. It means that if I rotate this element inside the material, how much? Because I move from A to sigma 1. I move clockwise in this direction. How much? You must measure it there. And it is 40 degrees, actually 45 degrees. This is called theta 1, double theta 1. Any angle on Mohr circle is doubled. And if you derive the formula for Mohr circle, you reach to an equations of a circle which is based on 2 theta. Okay, here I must move from this element, rotate is to 22.5 degrees in this direction. Then I got this x-axis, this is the original direction, and I move 22 in clockwise. If it is the center, 22.5 is here. I must rotate the surface A to this surface, perpendicular to this. It means that this surface A is rotated 22.5 degrees. This is the stress of principal axis, and we show stresses on this element. This is sigma 1, 920. This is sigma 2, minus 120. You can put minus or you can cancel it, but it is compressive. Show it's compressive is enough. Then this surface rotates to this state, and the normal stress becomes maximum inside the material. If any particle which has 22.5 degrees with respect to the particle that we calculated the stress on that, it has the maximum stresses in clockwise direction. What about tau max? I wanted to show a stress that tau is also max on that. Look, from A to reach to this point, I have to move at this one, counterclockwise. How much? 45 again. This is to theta 2, 45. And theta 2 is 22.5 as well. It means that with respect to this, I must rotate 22.5 degrees, or with respect to sigma 1, I must rotate 90 degrees in Mohr circle and 45 degrees in the element. With respect to this element, if I rotate 45 degrees with respect to this line, I reach the state of stress that tau is max. Okay, then you can do this one. Previous axis, previous surface, just rotate 220 degrees. This surface. Or this axis, let's use 22.5. Then that's the face, new face of A, this side. I rotate it 22.5 degrees. Construct the element on that. Then at this one, we have tau max, which is positive, means counterclockwise, clockwise. And the other one should be in this direction, other surfaces. It's like that, okay? Then This is tau. What about the normal stresses? Normal stress when the tau is max is equal to this amount. Point C shows the normal stress during the maximum shear stress inside the material. How much is it? It is actually 100, 200, 300, and 300 would be close to 500, I think. I don't draw clearly, but this shows that it is 490, for example, and both are tensile. You can use formula to find the exact value, maybe more than a little 500 or 510 or 12, I think. But graphically, we accept this. I don't use a proper scale on that. If you use proper scale, it will reach to the stress at a little more than 490. But this maximum shear stress is how much? It was actually the maximum shear stress here was equal to, let's measure that, 100, 200, 300, 400, 500. Yes, sir. That's the maximum shear. Oh, this is 400, 200, 300. This is 400, sorry. 318, 319, you can say. Yeah, let's say 319, close to 400. Then this is the state of stress when tau is max. This is also principal stresses. These are also called principal stresses. And if we use Mohr circle to see what is going on inside the material. This is not in our control. Okay. Then that's the first video about the how to draw Mohr circle, and in another video we draw Mohr circle in different state that we have sigma y as well on the state of stress, and also in special cases we draw Mohr circle as well. Thank you for watching. See you in the next video.